A very good afternoon, good evening, and good morning to all. I, Dr. Pallavi Saxena, SSC member of iLEAPS, and Dr. Samina, Project Administrator, iLEAPS, welcomes you all on the occasion of our second talk in iLEAPS Global Colloquium Series 2023. So after the successful completion of iLEAPS Global Colloquium Series 2022, we have decided to continue with the series. So we have already been done the first talk that has been from Dr. Sachin Gude from Indian Institute of Tropical Meteorology, Pune, and also our co-chair iLEAPS. So now we have the privilege of our second talk by Professor Murphy. So before I go into the detail, let's have a short introduction about iLEAPS. So iLEAPS is Integrated Land and Atmosphere Interactions, which is a global research project of Future Earth. iLEAPS provides understanding of how interacting physical, chemical, and biological processes transport and transform energy and matter through the land-atmosphere interface. The prime objective of this colloquium is to introduce the scientific community with the distinguished and significant work of eminent scientists all over the world. So basically, it's a very bright opportunity for early career researchers especially to interact with the distinguished speakers and establish the bridge between the ideas and knowledge through this platform. So our today's speaker is Professor Claire Murphy, who is the director of the Center for Atmospheric Chemistry at the University of Wollongong, Australia. So her research is focused on understanding the changing composition and chemistry of the atmosphere with long-term interest in fire emissions, air quality, and remote sensing of the atmosphere. More recently, she has branched out into the study of biogenic emissions, as these are poorly constrained in Australian emission inventories. So she's currently been served as co-chair of IGAC project and as a member of the International Commission on Atmospheric Chemistry and Global Pollution. So prior to her time as an Australian academic, she was a part-time researcher, full-time mother, and she studied for her own PhD at the University of Wollongong. Before immigrating to Australia in 2002, she worked for 12 years as a government scientist in the UK's National Physical Laboratory. So today she will be speaking on the characterizing organics and aerosol loading in Australia 2020, that is Koala 2020 campaign. And that campaign is basically been discussed about the challenges of organizing a campaign like Koala and highlight some of the most interesting outcomes they have found so far in the ongoing efforts to analyze and interpret the data related to biogenic VOCs. So there is one small instruction to the participants. If they want to ask from the speaker, you can please write it down in the question and answer box, and we can take up your questions. So I am very much privileged to once again invite Professor Claire. Professor Claire, now the floor is all yours.
Okay, hopefully this is going to work and you can all hear me. Is that right? Can you see my screen okay?
Yeah. Looks good, perfect.
Okay, so yes, I was asked to give a talk and I decided that the best fit for iLEAPS was probably this campaign that I ran in 2020 called Koala. And as you, this first slide is just to show you a cute koala, and that we decided to call the campaign Koala because it was about Australia and basically to gain some interest in that. The other thing that I want to show you from this slide is that I have a very large number of co-authors because this campaign involved a really large number of people who got involved. So what I want to talk to you about today is basically a bit about planning a campaign. And just to give you some idea of what went into making the campaign Koala 2020 happen in the end. And then I'm going to talk about some of the things that we actually managed to measure and a little bit about the unexpected challenges we faced. And the last part of the talk, I will give you a selection of the results that I hope will be interesting to the iLEAPS audience. So the first thing about planning a campaign is to identify a gap in our knowledge. Why do you want to run a campaign? And for Koala, that really came from a push from Catherine Emerson of CSIRO about how poorly we understood biogenic VOC emissions in Australia. And the second challenge for the campaign is finding somewhere where you can run it that's going to work. And the last part really is drumming up interest from collaborators and finding funding to make a campaign like that happen. So to start with, a bit of a busy slide here, but this is really the crux of why we wanted to run Koala. So MEGAN, which I hope you've heard of, I think it stands for the measurement of emissions of gases from something from nature, and aerosols from nature maybe, is Alex Gunther's model of emissions from nature. And this is showing you a slide that firstly on the top here, hopefully you can see my cursor here, the top is the whole of the world, and you can see that there are some bright colours down here in Australia. And so this is the austral summer, and you can really see that that it's pretty lit up here. And zooming in on the southeastern part of Australia, you can see Sydney and Tumbarumba, where some other measurements were made, and Melbourne. And you can see that really we've got very high isoprene emission factors predicted by MEGAN here. So a lot of VOCs in the atmosphere. And now to this next panel over here, what we're seeing is an image from the satellite OMI showing total column amounts of NO2. And what you can see is that there's not a lot of colour down in the blue here over Australia. And so what we're seeing is that we have very high levels of VOCs and very low levels of NOx. So that's quite an interesting atmospheric regime for new particle formation. And finally, at the bottom here, I'm just showing one of the existing campaigns, and it is observations made of isoprene, so atmospheric concentrations along here, and it's just a time series. So what was observed and what was predicted by the CSIRO model using MEGAN, and on the left-hand side, isoprene, on the right-hand side, monoterpenes. And what we can see is that the model using MEGAN is over-predicting isoprene by a factor of about 3 and under-predicting monoterpenes by a similar amount. And so we've got something missing in our understanding here, and really that's the crux of what we're trying to understand. So we get presented by two main questions which are being posed by Koala. The first one being, what are the real emission rates of isoprene monoterpenes? And while we're at it, some of the other biogenic VOCs, and how do these vary under different conditions of temperature and photosynthetic radiation? And what are the main drivers of new particle formation events under this unusually high VOC and low NOx regime? So having posed our question, we've got a name for our campaign. That's always important. Then we needed to locate a site. And what I'm showing you here is a picture of Australia up here with Brisbane, Sydney and Melbourne marked. And then zooming in on Sydney, you can see a little bit of what's a few sites marked here. And to this side, this is also Sydney. Chullora is marked. This is the main air quality super site, with the most instrumented air quality monitoring site in New South Wales. But these three sites were New South Wales air quality monitoring sites that we looked at for a long time as the most likely place we wanted to run a campaign. One was in Richmond, but we ruled that out in the end as not being surrounded by enough of the dense forest that we were really after seeing. And then we had two really forested sites, Oakdale and Bargo, and these both had records going back about 3 decades of air quality measurements, making them really ideal. They really had a lot of forest available for, nearby, and we wanted an open area because if you go deep into the forest, it's been seen sometimes that because isoprene is being emitted from the canopy, that it doesn't necessarily dissipate down to the ground, and we were making measurements quite close to the ground. But in the end, we found that none of these sites were going to be possible simply from the fact that we could not get enough electrical power there, and the cost of trying to install more power there was actually prohibitive. So if you want to make measurements in a place and have a lot of forested areas and a lot of power, what we found was scout camps were the place to go. So we found this place called Cataract Scout Camp in this area. So here's Sydney. There's a site here called Anstow, which I'll talk about a bit later. Wollongong is where the university where our work is, and we have this big forested area around to the south of Sydney and to the north of Wollongong, and right in the middle of it is this scout camp, lots and lots of forest and spectacular amounts of power. So a great thing if you're running a campaign is to go and do a mini campaign as a bit of a trial. We have this facility called Airbox, which you see being delivered here for this pre-runner campaign, and that was a really valuable experience. Airbox was between two different campaigns on a ship, and it needed to be housed somewhere in the meantime, and we decided to deliver it to Cataract and do a little measurement campaign over 4 weeks. It was really useful. We got to know the staff at the camp. We got to know all the processes there. We found out how amazingly good the internet was because they had some massive scout jamboree and had installed great internet there. Each of the 10 campsites that they had there had 4 power blocks with 2 3-phase and 4 15-amp mains on each of these sites. So we had absolutely plenty of power to run all the different instruments, and the site was characterized with the measurements that we made as really low in carbon monoxide and low in NOx. So drumming up interest in a campaign, really, this is in terms of if you want to try and run a big campaign, this is one of the main things you need to do is to try and get people interested in it. And we got a huge good head start in this by having interest from the NCAR group in the US. And we then kind of capitalized that by running side meetings at the IGAC conferences in 2016 and 2018. At one stage, we had a white paper for koala and huge plans to bring the NCAR DC-8 out to run alongside Airbox, and that was our first plan. We ran into trouble with that pretty quickly because we found that the nearby airport in Wollongong, the DC-8 could not land fully fueled. It could only land with like half a tank of fuel, so that was going to be problematic. And it didn't look like NCAR would get funding for that. So on our second generation white paper, and this is what's shown in this schematic here, NCAR were going to bring tall towers out here and run a campaign called Koala Bear to make flux measurements in the canopy. And the UK group were going to bring the NERC FAM in a campaign called Talent, really looking at how much NOx you needed to start the new particle formation events happening. And Joey was the campaign that us Australians were going to run. It was called Joey because koalas have babies that are called Joeys. And we went ahead with that campaign by ourselves. But great plans are also well, but you can't always get what you want. And we were hit by problems. There was no US funding given for the Koala Bear program. No UK funding came up for Talent. But the window to run the campaign was the funding that I had, which was a 6-year grant looking at air quality. That was closing because that money needed to be finished, the whole project needed to be spent out by the middle of 2020. So we needed to decide whether to go ahead anyway, and late in 2019, we decided we should take the opportunities that we had. So we renamed Koala 2020 in case any of these further campaigns might get funding in the future. So what we managed was a campaign called Koala Joeys, which I'll touch on very briefly. We ran it in 2019 at that site Ansto that I pointed out to you on that map earlier. And what we did was we ran a GCMS system looking at biogenic VOCs, but also anthropogenic VOCs in the atmosphere, and see how they changed across different seasons. And then the Koala 2020, it had an Australian team, including my university, the University of Wollongong, the CSIRO, which is the Australian National Research Laboratory, the University of Sydney, and the Airbox Consortium. And I showed you a picture of Airbox in the mini pre-campaign, and that's actually run by a whole consortium of universities within Australia. We also had local support from the New South Wales air quality monitoring people. We had collaborators at Georgia Tech who sent a PTRMS TOF and a PhD student to run it. We had 2 scientists come from Nagoya University in Japan to run filter measurements. We had the University of California involved with Alex Gunther, who sent tubes, which we ran and then sent back for him to analyze. And in a similar fashion, the University of Lancaster by Kirsty Ashworth sent VOC tubes and some soil emission chambers, and we ran some NOx emission and VOC emission experiments with those. So going on to part B of my talk, talking about actually running the campaign, we had a campaign of continuous atmospheric composition measurements. We had the filter measurements the Japanese were running. We had the soil measurements, and we had measurements of emissions from trees, and a number of unexpected challenges which we hit. So here is a vision of kind of a map of the site. So Cataract Scout Camp, here's Ansto again, where the pre-campaign Koala Joeys ran in 2019. The actual measurement days were January the 15th to March the 23rd of 2020. Here's Cataract Scout Camp, and zooming in, you can see here is where we put Airbox. Here is the air quality monitoring station that came from the New South Wales air quality measurement people. The filters were in this open space here. The PTRMS was installed in its own office here, and we had a filter clean room in a separate office here. And out over in the edge here was the soil sampling and soil emissions measurements. So zooming in a little bit from that, a photograph from a drone. Here's the air quality monitoring station. This is Airbox. This is a scribbly gum and the PTRMS right next to it. And I'll talk about an experiment, particularly on this tree right at the end of the talk. And here's the filter stuff. And there was a kind of kitchen here where we could go and make cups of tea and things. So the air quality monitoring station was the first set of instruments to be installed in December 2019. This measures NOx, SO2, ozone, carbon monoxide, PM10 and PM2.5. There's a nephelometer for visibility, and they've also got wind speed, wind direction, temperature, and humidity. And all of the measurements are made available at 1 minute resolution. So thanks to our collaborators at the New South Wales DPI who make these measurements. Airbox came in at the beginning, so in the middle of January, at the start of the main campaign. And within Airbox, there's an aerosol, a TOF ACSM that can measure aerosol composition in PM1 aerosol size distribution measured by SNPS. We've got counters for CN and for CCN, so the number concentration of particles, carbon monoxide, carbon dioxide, methane, nitrous oxide and radon. Again, most of these measured at 1 minute resolution. And so thanks to our collaborators at CSIRO for their help installing all of this. The PTRMS TOF was sent from Georgia Tech, so thanks to Jen Kaiser and Asha Moat, who's pictured here. The PGRMS TOF can measure a number of biogenic VOCs, particularly in this talk. I'll talk about isoprene and its oxidation products and the sum of the monoterpenes. But there's also a number of other VOCs that it can measure, all at 1 minute resolution. This is setting up the 10-meter mast, thanks to our collaborators at ANSTO for the mast. There was a sonic on this and the inlet for the PGRMS TOF. And here's a local goanna who seemed to be checking out the mast once we had it installed. The filter sampling, Michi and Sho from the University of Nagoya are shown here. So they were, and alongside a student at Wollongong, Jack Dang. So we measured using a high vol PM1 and total suspended particles with a low vol. Every 1 or 2 days, the filters were changed. Coarse particles in an impactor will run every 5 days at the beginning of the campaign, every 14 days at the end of the campaign. And these filters were sent back to Japan for offline chemical structures to work out the chemical composition of the filters. The soil emission measurements, so Kirsty Ashworth sent these soil chambers and that went in around this scribbly gum, and basically there's a blank and there's a chamber, and we measured NOx concentrations, so you could look at NOx fluxes and how they varied with temperature, soil temperature and moisture. We also ran towards the end of the campaign some VOC tubes, but the analysis of them was COVID impacted, which I'll talk about a little bit later. So the measurements I think will probably be of most interest to this audience will be the measurement emissions from trees. So what we're seeing here is a kind of enclosure. So you wrap this enclosure around a branch of a tree that you're trying to analyze. There's a pump that pumps like 12 litres per minute of flow over the branch, and at the side you're pumping through into a VOC tube at a set rate. So you can then analyze that tube for the total concentrations and the flow rate, and you can get an emission rate. So thanks to Malcolm Possel and Danica Parnell from the University of Sydney, who measured half of these, provided these enclosures, showed us how to run them, made the measurements in January, and left them with us to make measurements in March later on, and to Alex Gunther from the University of California, Irvine, who also analysed a set of tubes from these enclosures. So we ran we ran these for 3 repeats of 3 different trees, 6 different tree species, and in January and in March. So with any big campaign with lots of instruments, predictably we had some instrument problems. This was with the PGRMS TOF. So this is a Wollongong colleague of mine, Travis, who's cleaning out some of the instrument to get it up and running again. Some other points about the campaign: we had 17 staff involved in total on site. I spent all but 4 days of the 9-week campaign on site for at least an hour or 2, but often for 7, 8 or 9 hours a day. We had to run daily instrument checks. Other major failures was the MaxDOAS failed on day 1 due to a broken optical fibre, which we couldn't get replaced in time for the campaign. The other major instrument failures were the PGRMS TOF that I showed you, and the ACSM had to go off for another campaign, meaning that we had a relatively short overlap when we had all of the instruments that we had planned to be actually running together. So the best laid planning for such a campaign is really, really important, but you can't plan for everything. So because I don't think I can be amusing talking constantly for 40 minutes, I thought we would do a little poll. So I hope this will work. And how this works is you get out your phone or your laptop and you either follow this link or try and bring up another link for you to follow, and we can have a little poll here. So bear with me a minute. So I think that if you use that that link, you will be able to get to the poll. So maybe I'm going to wait a minute now, and hopefully you can all get that poll running. And so you need to get out your phone and either put in, or on your laptop, you need to put in that address, or using your phone, you need to use the QR code, and it should bring you up to a voting poll. I can't actually see whether you guys are managing this or not. So I'm gonna hope that you've managed that, and give another few seconds, and then I'm gonna start the poll. Okay, right, I'm gonna start it now, and let's see how we go. So what I want you to do is to guess which of these hazards we had included in the risk assessments when we thought about running the campaign. Okay, you can add multiple choices. You don't need to just choose one or two. I'll give it. Looks like people thought bushfires would be a major one, and that certainly did turn out to be the case. All right, so I think we've got a pretty good guess here. In fact, the only one that was we didn't think about was in that point was the volcanic eruption. But you have correctly identified that we thought snake bites might be a problem, sunburn or sunstroke, and bushfires. So I'm going to go on the next question, which is what actually happened. Which of the hazards did we encounter and did affect koala 2020? So hopefully you can go ahead and vote again. All right, so thank you for having that vote. Yes, indeed, in terms of the hazards that we encountered for koala 2020, of course, it coincided with the worst bushfires in recorded history in Australia. We luckily did escape without any snake bites. We had maybe a little bit of sunburn, but nothing major, so we escaped mainly from that. Sadly, we were impacted by a volcanic eruption because the PGRMS TOF got delayed by the Big Manila volcanic eruption, and it was delayed about 10 days before it could get shipped out of Manila after all of the aircraft were downed by the smoke, the plume, the eruption plume. And clearly at the end of koala 2020, we were impacted by the beginning of the COVID-19 pandemic. And we also experienced a once in 3 decades hail and flooding event that put out the Black Summer bushfires and also caused us some significant leaks. So at this point, I will leave that and go back to the presentation. So hopefully you can see that now. I think I've probably said, yeah, a whole lot of unexpected challenges, and I guess every campaign is probably hit by that. But the COVID situation really did scupper the plans, particularly with the tubes going back to Lancaster and Caltech. They then got locked out of their unis, and there was a huge delay in getting all of that up and running. So the first half of Koala 2020 coincided with the end of the Black Summer fires, and here's an image from Himawari showing the widespread fires and smoke on February 3rd. By February 5th, we had this massive rain event, and it really did clear out the atmosphere. So we had an interesting first few weeks of smoke, which we weren't really expecting, and that basically became pretty much a separate campaign for us in terms of the science we could get out of it. But it really wasn't until that kind of second week of February that we had everything up and running, and we could really look at the questions that we wanted to look at, which was the emissions, looking at how that biogenic emissions changed the chemistry in the atmosphere that we were wanting to understand. So on to part 3, I guess part C of this talk. What we found so far, I want to talk about around those main first questions: the emissions from the trees, including particularly the scribbly gum, and if I get time, also talking about the new particle formation events. So the joint organic emissions year-long study was how we finally came up with the acronym to match Joey's. So this was what they're saying, this pre-campaign that ran in 2019, and it ran from this site in Anstey. And really, the main finding that I wanted to point out here was that the main monoterpenes that we found, cymene and eucalyptol, were much longer lived than the typical alpha-pinene that dominates in the Northern Hemisphere. And so the concentrations in the atmosphere are higher, which might explain some of that mismatch with Megan that I showed at the beginning, which is part of the reasoning for us to want to do the koala campaign. In terms of the monoterpenes being higher than what was being predicted. But the contribution to secondary organic aerosol might be less. And if you're interested in that, there's a paper out here. You can look at it in the journal Atmosphere. So back to the main questions that we posed for Koala 2020, which were: what are the emission rates of isoprene monoterpenes and other BVACs, and how do they vary under different conditions? So that's what I'm going to talk about now. So going back to these tree emissions, these enclosures, and the different, remember we ran it for 6 different tree species. We did 3 repeats in January and 3 repeats in March. So 3 different trees of the same species in the area. So this is just looking at the results for isoprene emissions. So it's in micrograms per gram of dry weight of leaves out of the branch per hour. And these are the 6 different species. So in this section A, this is just the pure emission rates as they were measured. And in the second panel in B, they have been standardized using a set leaf temperature of 303 Kelvin and a set PAR, standard photoactive radiation of 1,000 micromoles per meter per second. So this is using the relationships that we believe the emissions will have with temperature and PAR. So it's based on the Megan model. And what you can see is that the emission rates that we see for isoprene are really quite variable, and they are not different between January and March, except surprisingly for the species Maluka I can't even pronounce it, Quiquenerva. I'm used to using them by its common name. But unusually, the autumn March value is actually higher, the emission rate, than what we measured in January. So Malcolm Postle was running a model of these emissions. So they're using the plant functional type, the basic emission rate of 10,000 micrograms per meter squared per hour from Gunther's paper in 2012, I mean, for broad green everleaf temperate trees, and converting it into micrograms per gram of dry weight per hour using the measured leaf mass area from the site. And so black is basically the raw measurements, and red is just the leaf area plus or minus 2 standard deviations. And superimposed on that are the measurements that we actually made from the different tree species. And what you can see is basically we're massively overestimating the isoprene, as we stated at the beginning. So effectively, these measurements are confirming what we found from the previous campaigns, that the isoprene appears to be much less than is predicted by Megan. So Megan 2.1 overestimates by about a factor of 4, and the Emerson 2020 different, which is a slightly different version of the tree types, it overestimates by a factor of 2.5. So we're still really, really high on the isoprene in terms of our understanding. So this is looking at the different BVOCs, and so we've got alpha pinene, beta pinene, P-cymene, which is the one that we saw was really quite a dominant one from the Ansto campaign, the koala joeys. And again, this is as measured, and this is normalized to standard temperature and PAR. And then we have limonene, B-cineol, and beta-caryophyllene. And again, what we're seeing is there's no difference between what we're measuring in January and March once you standardize for temperature and PAR. Okay, so that was all the measurements that we made using those enclosures and the tubes. But we did a more intense experiment on these lovely scribbly gum trees, which were one of the dominant species in the site. And what you can see, this main big scribbly gum, I pointed it out to you right at the beginning and showed you that the mast was right next to it. The scribbly gum, the soil measurements were also by scribbly gum. And here is the PTRMS lab being delivered, and it's being delivered right next to this PTRMS so that we can perform this experiment, which we did right at the end of the campaign. And so what we did with this experiment is we used one of these enclosures and wrapped a branch of the scribbly gum in it, but instead of pumping, we're still running 12 litres per minute, but instead of running to a tube, we're running to the PTRMS. And so we had it on a rotation. So we ran 10 minutes from the enclosure into the PTRMS, with the PTRMS measuring every 30 seconds. And then it would switch and measure for 10 minutes up the mast. And then it would switch for 10 minutes and measure in the open leaves. And then it would go back 10 minutes in the enclosure, 10 minutes up the mast, 10 minutes into open leaves. And we kept going for 24 hours roughly on each of these branches, so that we saw daytime and nighttime emissions right the way through. Now, I have not worked out this data, but basically the reason to also go into an open branch was so that we could see, were we stressing the branch at all? Do we see a different combination of chemicals coming out of here compared to what we saw in the enclosure? And the reason to measure at the mast is so that we can subtract the ambient measurements and really get to the emissions of what was coming from the branch at the time. So this is the first branch. It ran for more than 24 hours in the end, and then we cut it off and we took it back to Malcolm's lab for analysis of its total dry mass and the leaf area. This was the second branch, which is kind of the other side, of the canopy. It ran for approximately 24 hours as well, and then we cut it off for mass and leaf area analysis. Just pointing out, when you look at this branch, you can see that there are a lot of young leaves here. It looks quite different in terms of the colour from the other branches. And this is the third branch, ran for approximately 24 hours. And then here it is cut off to be sent back for mass and leaf area analysis. Okay, so what did we find? Oh, I forget, right at the end, just before we packed up in a hurry for the COVID lockdown, we ran the PTRS top around for a few rounds again through a blank so that we could see what we were observing in the enclosure without a branch inside it. So when we're calculating the emission rates, what we're doing is we're looking at the concentrations that we measured from here. We subtract the concentration from up the mast and the concentration that we measured in the enclosure, and that gives us an enhanced concentration. And then we turn that into an emission rate by multiplying by the number of moles in 12 litres of air, which is pumping through every minute, multiply that by 60 to get it into hours, and by the molecular weight of the VOC that we're after, so that we get micrograms per hour emitted. And then we put that either in terms of the dry weight of the branch or the leaf area of the branch. So now I'm showing you some of the results. So the top, this is over the 3 days that we ran this experiment. The top one is the air temperature in the enclosure. So we're getting up to pretty much 50 degrees temperature in the enclosure from an ambient one, more going between sort of 20 and 35. The second panel is the photoactive radiation, and you can see that that's obviously goes to 0 at night, and then there's a bit of scattered cloud about. Certainly the second day is a little bit cooler and there's less radiation about, but really when we look at the isoprene emissions, you can see that they're much greater from branch 1, very much reduced for branch 2, and branch 3 is sort of in between, but more like branch 1 than branch 2. And here, so superimposing these branches on top, you can really see that it's really that what's driving this smaller emission of isoprene seems to be these young leaves. Okay, so we can look at the isoprene, and in this instance, I've summed the isoprene and the oxidation products. So, and then plotted that against the PAR C, and what we can see is that it's really increasing. It's color coded by the temperature, so we're getting these really large emissions when we've got very high temperatures and high radiation levels, really bright on the brightest, sunniest day. And we can then compare that to the model results that Malcolm ran. And what I'm showing you here on the left is the kind of scaling that we would see in terms of the emissions that you get as they change with temperature. And the Gunther original Megan basically increases up to about a threshold of 40 when the trees start to stress and start producing as much isoprene. But in Catherine Emerson's reworked analysis, she shows it's still going up to a much higher temperature. And here's showing a comparison of them. And when we compare the measurements that we're getting, we're seeing a closer fit to Emerson's model in terms of the measurements that we saw from the squiggly gun. And here's the monoterpenes, and they're also increasing quite linearly with PAR, pretty much as expected. And we're seeing a very similar thing with methanol here. Okay, so summarizing this, the emission rates of isoprene, monoterpenes, and methanol have been calculated with respect to leaf area and dry weight of the branch. We found significantly lower emission rates from the branch with fresh young leaves than for branches with more mature leaves, and the emissions increased with PAR and temperature as expected. looking closer to the Emerson model than Megan, but we need to confirm that looking a bit more in detail. Okay, so I'm going to take a break again because I'm bored of my own voice, and we're going to go back to the survey, and this time I'm going to ask you to try and estimate what it cost us to run Koala 2020. So let me see if I can go back to hopefully you can go back to it, and let me see. So bear with me. All right, hopefully you can see that. Oh, no, I don't think I want that one. Okay, we'll go back to this this screen. Hopefully that allows you to get back in. Okay, so in this question, I'm asking you how much money we had available in Australia to run the Koala 2020. And we've got a few different votes here. Okay, so actually no one has voted for the correct answer, which was 40,000. I had 60,000 Australian dollars to run Koala 2020 from the Australian point of view. But maybe you can guess better if I move on to the next question, which was what was the full economic cost of running Koala 2020, including all the in-kind contributions. So this is basically including all of the collaborators and how much funding they used and all of our own time. So it looks like this time the correct answer is the most popular. I have no idea. As I said, we had collaborators from the US, we've had collaborators from Japan, we had collaborators from the UK, and we had a lot of collaborators from Australia. And I have not even attempted to try and add up the total cost. But the point that I'm making with these two questions is really that, you know, in terms of, from my point of view, running this campaign, I only had a small amount of funding in order to make it work. But by the collaborators that I've managed to achieve, I managed to get interested and came along, we really had the capacity to run a big campaign. So a small amount of money can sometimes go a long way. So I am not sure whether I still have time. I think maybe I'm going to crash out of this and take some questions, and maybe if we have time, I might come back to looking at the new particle formation events. So I'm going to skip through and have some talking about some final comments. We found some money to run the campaign, and as I said, a lot of people came. A lot of people were interested and excited to come and make these measurements with us. We had no money for an analysis and write-up, so what I did do when I had staff, and I prioritised getting the data finalised and published in the Pangea database, and I'm now still slowly working out the data and the papers now, and I suspect it will keep me entertained for some time yet. So thank you. I will stop now. Okay, maybe we can host some questions.
Oh, thank you very much, Professor Murphy. Oh, that was really interesting, and you really kept us engaged with this poll, and it's really an exciting talk. So I have asked the participants to pose questions in the question session, and let me see if I have any questions there. I don't see anything. Participants, you can please post your questions in the question session, and then I'll read it out. Or if anybody wants to speak, just raise your hands. I can unmute you also. Yeah, David, go ahead. It seems like you are self-muted. Can you just unmute yourself?
Am I unmuted now? Okay. Yeah.
Yeah, we can hear you.
Yeah. Thank you very much, Claire. That's very interesting talk and presentation. A lot of work as well. As I can imagine, I was surprised at the cost, initial cost you gave. That was shown. But obviously, we didn't know much more about other collaborators. The key, I saw you focus on 6 species on the study. But I would have just wanted to know also what was the composition of your site, the species, 3 species? Were these the main dominant species you focused on, or there were more than that? And what impact does it have in the final emission rates and measurements you are undertaking on the sites? Thank you.
Yeah, so I can only partially answer that. Partly for my complete ignorance in being not an ecologist at all, but an atmospheric chemist. But luckily I have a friend who is an ecologist from the university who came up and screened it and said that the 6 species we chose were the 6 most common on the site that we were making the ambient measurements from. And they were by and large pretty common species in the area. And as I said, that's probably the most common species was that scribbly gum, and hence why we concentrated on that one tree to make those diurnal measurements. We did do, and I have a slide that I could probably show, maybe taking it out, and I'm going to take it out. But we made some measurements from the tubes. We went to 3 other sites and made some just ambient measurements on the tubes. We made some tube measurements right by where the PTRMS was sampling as well, but near the ground, just to see whether the kind of general compounds that we were measuring on the tubes were the same at the cataract site as we were at these different satellite sites. And what we found, yes, was indeed we were seeing pretty much the same compounds at similar levels. So we're pretty confident that we didn't choose a weird site that was not representative of the general area. But whether, 6 6 species, it would have been nice to measure a lot more than that. Eucalypts are hugely dominant in Australia. They're 70% of the species are eucalypts of one type or another. But as you saw with the isoprene measurements that we made, there was quite a difference between some of the different species. So if we could find some more money and some more time, and if we ever finish writing up this stuff, we could go back, and certainly there's plenty more to find out. We haven't exhausted all the things that we would do. We could measure, but yeah, hopefully what we did is reasonably representative. I hope that answers your question. Okay.
It does. Thank you.
Any more questions? I don't see any other questions. They're not even in the question session, also not posted anything.
I have a question, Samina.
Just go ahead.
Is your project, Professor Murphy, is planning to do some policy measures related to green belt development in your country?
So there were some thoughts about this in terms of, obviously there's a lot of interest in what sort of trees you would be best to plant in the city. But one of the we never got to that point in this project, and part of the thing that one of the things that I still have no gut feeling about at all. Normally in an area where you've been involved in research, you have some sort of feeling about how things would what matters and what doesn't matter. But when I think about a place like Sydney and planting urban trees, I have no idea about whether the choice of species that you would plant inside the city makes a big difference or not. And if you can think back to some of the maps that I showed you, you know, Sydney sits in this like big basin surrounded by really quite densely forested areas, and it has like because it sits in this basin, the kind of cold air sinks through the forested areas and brings VOC rich air, typically in the mornings, and then we get like an afternoon sea breeze which kind of pushes stuff into the west. So we tend to get kind of worse ozone pollution in the west of the city. And I really don't know whether the small, obviously there's quite a lot of trees still in Sydney. It's not a very concreted city. It's quite green, but whether with the planting things, whether the amount of BVOCs that are emitted by the trees that will be planted by different councils are significant compared to the big forested areas around. I really have no idea. I think it would require probably quite a detailed modelling study to answer that question. And it could be because they're right there in the city that they matter a lot, or it could be that because there's only a few trees and surrounded by these massive forests, it really doesn't make a lot of difference. And I have no feeling one for the other. Or, so that doesn't answer your question at all, really. But it's like, maybe it's a reason why we never quite got there in terms of the policy of what you should plant. So, and I guess we're also, these questions are often driven by other things like what's going to survive in the harshening climate that we're being exposed to, and the fire risks and the other issues. So.
Thank you, Professor. There's a question from Gary. Gary, you can ask your.
All right. Thank you, Samina. Thank you very much, Claire. Very enjoyed your talk a lot. I guess I was going to ask about the modelling, the comparisons with Megan and the Emerson. So are these kind of default values that you're comparing with in Megan and the Emerson work, or is, you know, I guess what I was asking is a bit more detail about that aspect of the study, about the modelling, and what kind of factors are, you know, what are these based on generic trees or broadleaf trees or eucalypts, or, you know, and you've got some very local factors there. So I'm kind of interested, just, you know.
Yeah, so I'll try to explain it as best I can, given that it wasn't me that was modelling it, and it's a little bit.
Sure.
But basically, they were scaled, and so effectively that kind of gamma value, if I understand it, you when you're looking at the total emissions, and we were trying to scale the models to match what we measured, say from the scribbly gum, you couldn't get a single factor that was going to model those 3 branches or anything close. So you've got very different numbers trying to scale them to the 3. In the terms of the modeling, when I was showing, it was scaling by factor of 4 to Megan and a factor of 2.5 to Emerson. That was simply taking like what the 2 different models would consider being that plant type. You know, if you look at a map, and I've forgotten the name of, and I feel really bad that I've forgotten what it's called, the iLEAPS audience, but basically you'll have a map of the different vegetation types, and that will feed in what you expect the emission factors to look like. And the main difference between the Emerson model and Megan, the 2 ones, is the type of vegetation maps that are used, but also this thing about when you, in terms of the light sensitivity and temperature sensitivity of the eucalypts in that area. So what the model, as I understood it, did was take the type of vegetation, but then scale it to the leaf area that was measured on the site, using basically the different trees that we looked at. So they did an analysis looking at actually what the density of vegetation was right around the site to scale it, and that's what he compared. And then I think I showed you something that was black, and the black was the model itself, and then they scaled it by two kind of standard deviations each way for the leaf area, and he was still like way off, basically. Still way too high. Did that answer your question, or am I just revealing my massive ignorance of this model and how it works?
No, that's fine. Thank you. It's very interesting. Yeah.
Thank you, Gary, and thank you, Professor. So there's a question from Mohammed Talib Latif. You can ask, please.
Hello, Claire. Thanks for very interesting
Hi, how are you going?
I'm Talib here. I just want to ask you, do you think that isoprene contribute to the contraction of surface ozone? Because in Malaysia now we have high contraction of ozone, but we still cannot find the main contributor to the ozone concentrations, especially in the suburban area between city center that contribute to NOx, as well as the suburban area that has a palm oil plantation that contribute to high concentration of isoprene.
Yeah, I mean, I would think so, that all of the BVOCs would contribute to the ozone loading, and that effectively, and to the particle loading as well. So sometimes we had a little bit of evidence. I didn't get time really to show it, but you know, there's some evidence that when the isoprene was really high, it might suppress some of the new particle formation. But my understanding is that any of the isoprene and any of the other BVOCs, you know, will be involved in ozone formation. Certainly, you know, in an area like this, we're NOx limited, but you really see quite a lot of, you know, it becomes quite active in these really hot days when there's a lot of biogenic VOCs about. You don't need a lot of NOx to start the chemistry to produce new particle formation and ozone. So you really see it in these hot days. Don't know whether that answers your question. Yeah, I think so. I don't know. We certainly can see the ozone going up in some of the same times as you see like the ambient concentration of the isoprene coming up, and the isoprene oxidation products, you know, are that isoprene is oxidizing really rapidly in this environment.
Thanks, Claire.
Okay, then I don't see any more questions or any raised hands. So maybe Pallavi, you can summarize and
Yes. Okay. Thank you very much, Professor Claire, for your enthralling talk. And it was really very wonderful to have the poll sessions. That was really very interesting. And we are very happy to see our present and the past SSC members with you in the Koala campaign, that is Christy and Alex Kutner. So before to finish up this session, let me sum up some of the highlights of your session. So Professor Murphy has talked about Koala campaign concentrating on biogenic VOCs in Australia. She explained that Megan model indicates Southeast Australia is isoprene hotspot, and OMI NO2 also shows that low isolated NOx sources in Australia and hence have high VOC, low NOx regime for NPF. The major research questions for this campaign are: what are the emission rates of isoprenes and monoterpenes, and what are the main drivers of NPF events? She also explained about the identification and selection of sites which are an open area near dense forest, and there is a problem of lot of power in Australia. She explained about drumming up interest in this campaign as NECAR interest, IGEC side meetings, NECAR tall towers, NERC farm, aircraft, airbox, and RV investigator. She also explained about the challenges in this campaign, like no US funding for koala, no UK funding for talent, and it becomes difficult to decide to go ahead with this work or not. She also explained about the measurements that have taken place, like in Koala Geo's 2019 campaign, where seasonal variability of VOCs using GCSM using GCSM has been involved. And there are many collaborators from different countries have been involved, like Australian team, local support, Georgia Tech, Nagoya University, and University of California and University of Lancaster. So this campaign ran from January 15 to March 23 at site Cataract Scout Park site in 2020. So air monitoring station was also installed in December 2019, and where NO, NO2, SO2, O3, CO, PM10, 2.5, and the meteorological parameters like visibility, wind speed, wind direction, temperature, etc. were monitored. This campaign also measured in airbox like aerosol composition, PM1 aerosol size, CN and CCN, CO, CO2, CH4, N2 or radon at 1 minute resolution. Then the instrument which has been responsible for capturing the BVOCs, that is PTR and MS-TOF, also set up and measured isoprene oxidation products, methanol, acetonitrile, and also other BVOCs. Then PM1 and TSP measured every 1 to 2 days, and coarse particles every 5 to 14 days, and offline AMS for chemical structures of by SOA rich OA, that is organic aerosol. So continuous NOx, that is chamber and blank experiments, VOC tubes of soil measurements were done from Lancaster University. And tree emissions were measured from 6 tree species and 3 more repeats have been there in January and in March enclosure, that is 12 liter per minute flow at 3 other nearby locations from the experimental site. And this has been contributed from University of California, Irvine. So first half of Koala 2020 coincided with the end of black summer fires and shows widespread fires and smoke. And the speaker has highlighted of February 3rd, 2020. She also explained about the observations like emissions from tree species having gum resins in it, so they have higher emissions. And koala Jewess dominant monoterpenes are longer lived. This means that concentrations are higher, but contribution to SOA may be less. So mean isoprene emissions from 6 plant species measured in Jan and March 2020 emission rates are highly variable within and among species, but consistent across the months except for isoprene from Melacoa. So from model results, that is Melicom posal boreal emission, broad emission rate of 10,000 microgram per meter square per hour from broad-leaved evergreen vegetation were commonly founded. Then VOC tube results shows that other BVOCs, again, no difference in Jan to March, one standardized for power and temperature. Then in terms of the specific tree species, that is E. hemostoma, that is a gum tree. So 24 hours per branch with the help of PTR TOF MS measurements were made as in different forms like enclosure, mast, open and branch, and repeated them. Then leaf area analysis were also being done from some of the branches of this tree species. And emission rates were calculated and the emissions were given in microgram per hour. She also explained about the time series rates of temperature, power and isoprene emissions and the variation of isoprene from different branches of the tree. And emission rates of isoprene, monoterpene and methanol have been calculated. Then at the last, they are being prioritized the data to Pangea and likely to compile this work for publication. So I have tried my best to compile the things in a brief form, and I apologize if something has been, not been described properly. So now we come to the end of this session, and before I officially declare this session to be closed, on behalf of our iLEAPS committee, we would like to thank our speaker, Professor Claire, for giving her time out from her busy schedule and accept our invitation to deliver this wonderful talk. And at last, I would like to thank iLEAPS team and iLEAPS for giving us the opportunity to conduct this Colloquium series. Thank you very much.
Thank you, Professor. There is a request. There is a request from David. Kindly share links of the publication. So
Sure.
yeah. So if you could send us, or either you can share in chat now, or you can send me later. Then I'll distribute it.
I will send you the links. Yeah, sure.
Thank you very much. Thank you.
Yeah. Okay, thank you very much. So with that, we are closing the webinar.
See you then. Bye-bye.